Grad students spend a ton of time writing code for their research. And one of the most common questions I get from students is how much time should I spend refining my code and getting users versus just publishing a paper and moving on? And I want to give one extreme answer to that question. 12 years ago as a grad student, I started a piece of research software called Python Tutor, which is an educational visual debugger to help people learn how to code. But instead of just publishing a paper and moving on, I've been refining the Python Tutor code over the past decade, so now it's reached over 10 million users in over 180 countries. So how was I able to keep Python Tutor going over all these years? Well, this paper presents 10 design guidelines I developed to help me do so, and they fall into 3 categories. 1 is user experience design, 2 is software architecture, and 3 is software development workflows. Okay, I'm going to start with 4 user experience guidelines that have helped me to scale Python Tutor. If you want to get a lot of users, your system has to be walk-up in use. For Python Tutor, someone just walks right up to it and starts writing and visualizing code. No installation, no accounts, and no logins. Next, it should just work no matter what users throw into it. So for Python Tutor, users could throw all sorts of complex code into it, and they expect to see it visualized correctly or else they're going to stop using it. Sharing, not hosting. Python Tutor makes it really easy to share and embed visualizations across the web. This benefits us because we avoid hosting any user-generated content, which helps us scale a lot better. Minimize options to keep the user experience as simple as possible. Python Tutor has 3 sets of options, but I still think that's too many. Okay, I changed shirts for the next section. I'm going to give 3 guidelines for software architecture now. The first one is to be stateless. So being stateless helps make your app more robust, scalable, and secure. Next, trying to keep up with the latest software toolkits, frameworks, and libraries is a never-ending battle. So that's why with Python Tutor, I use old technologies that have stood the test of time over the past decade or more. On a related note, maintaining and updating software dependencies across many years can be a huge pain, like this XKCD comic shows. That's why I strongly suggest to minimize dependencies as much as humanly possible. Okay, one final wardrobe change for the last section, software development workflows. This is me as a grad student 12 years ago when I started Python Tutor, and one way I've been able to keep it running for so long is by having it be a single developer project where I'm the only one who worked on the code. Another way is to start specific. I never intended this to be a large user-based, research platform or anything. And the last way is to actually ignore most users. So contrary to user-centered design, I think it's actually important to filter and ignore most user suggestions in order to keep your project sustained over a long time. Okay, so that was a super quick tour of my paper, which is about this topic of maintaining research software long-term in academia. And I love in QA to talk about things such as the trade-offs of taking the approach that I did with Python Tutor. I don't recommend it for every single research project, obviously, and also about broader issues of career incentives in academia for doing this sort of longer-term work. So I love to hear your thoughts in the Q&A.